Okay, so let's say I want to Laplace transform a function of t that's a three-part discontinuous function. Blank. Right? Yeah. First things first. Yeah, step function everything. So you need to take f of t and rewrite as step functions. So in the beginning, f was 1.
What?
Do you have to, because you're saying 0,
Yeah.
so you have to,
So-
it's a step function at t.
Yeah, so you could have u of t minus 0 here. Sure.
Okay.
I'm gonna blue that part.
And then before
I think
0, we don't care.
I'm gonna put that part in blue for reasons. Okay, times 1.
T squared? Or plus T squared?
Plus
U of t, too.
Oh, U of T minus.
u at t minus 2 times, okay, what did you want to turn on there?
T squared plus 1.
T squared plus 1.
But turn off 1.
And then you want to turn off 1, so you do t squared plus 1 minus 1. Okay, then what?
U T squared minus 4.
So you need a u at t minus 4. And what do you want to turn on at t minus 4, or at t is 4?
T cubed.
T cubed. So you put a t cubed in here. And what do you want to turn off?
T squared plus 1.
Like that?
Yeah.
Minus 1.
No?
You're missing a parenthesis.
Yeah.
You get that wrong.
Make sure you're subtracting the whole function you want to turn off. Otherwise, you'll accidentally turn on something else. And then you'll be really confused. No, I'm just kidding. You'll be confused anyway, because there's a lot of stuff here, right? These are ones where it's really, really crucial that you just go really slow and make sure every step is right. So, to double check, at time 0, I'm turning on 1. At time 2, I'm turning on t squared plus 1 and off 1. And then at t is 4, I'm turning on t cubed and turning off all of t squared plus 1. Okay, cool, good. And then I need to Laplace transform that, right? So, linearity is your friend, right? So you're going to have the Laplace transform of u, oops, u at t minus 0 times 1 plus the Laplace transform of u of t minus 2 times
T squared.
t squared plus the Laplace transform of u of t minus 4 times
T cubed minus T squared minus 1.
t cubed minus t squared minus 1. Okay, and then in each part, you need 2 bits.
Did we figure the minus 1 in that second Laplace, or is that not supposed to be?
Minus 1 plus 1.
Oh, okay.
Yep. Good eye, though, right? It's very easy to screw this up. You always want to be skeptical of your own algebra. Okay, so in here, what's tau? 0. What's f of t?
1.
F of t is 1. Guys with me? Okay. In this guy, what's tau?
2.
2. And f of t is t squared. Oh, and if I'm doing a good job, let me teach you, let me make good organizational habits. So those are tau 1 and tau 2, and F1 and F2. Over here, F is more annoying. F3 of t is t cubed minus t squared minus 1. And tau 3 is 4. Okay, so let me even write down what the line of the table I'm using is. So the line of the table I'm using is that the Laplace transform of t, u of t minus tau times f of t is,
Minus tau.
that's another part.
Yeah, that's
So this is the first thing, right? So I have the Laplace transform of the unit step function times f of t, and I get a e to the minus s tau
times
the Laplace transform of
f of t plus tau.
f of t plus tau. So the weird thing about the unit step function transforms is that you're going to feel like you're doing the Laplace transform part twice. You all see that? So up here, first stage, I have a e to the minus s times 0. E to the minus 0s.
We just make that 1, right?
Yep, and that's going to be 1. And then I have the Laplace transform of 1, and it should be evaluated at t plus 0, right? So that's going to be the Laplace transform of 1.
It wouldn't matter though, even if we had a 1 later on, it would just stay 1, right? Because we're not feeding the constant function anything.
Yeah. Okay, and then I have plus, there's the green marker I was looking for, plus, and in this bit from the red, I get a e
Minus 2s.
to the minus 2s, and then I get the Laplace transform of
T plus 2 quantity squared,
I get a t squared evaluated at t plus 2, right? So that should be the Laplace transform of t plus 2 quantity squared.
Oh god. I was just looking at f of 3, like.
Yeah.
Oh.
Okay, and then my third part is I have a plus e to the minus 4s, and then the Laplace transform of
T plus 4 cubed.
t plus 4 cubed minus t plus 4 squared minus 1. Cool. I'm going to erase the function I was Laplace transforming so we forget that happened. Okay, then what?
Table.
Not quite. Not quite ready for a table yet. Some of them I am. So,
Oh, yeah.
I guess lots of steps intermittently. Let's see. This one, I'm just going to table. Right? What are you going to get out of that?
1 over s times 1, yeah.
1 over s times 1 is probably 1 over s.
Hopefully.
Hopefully. That 1 over 0 thing before had me really tweaked, so I'm not sure anymore. But all right, then this guy.
E to the 2s
Distribute, extend.
So you got an e to the minus 2s, and then you've got, okay, so t plus 2 quantity squared is t squared plus 4t plus 4. So I think I've got the
2.
Laplace transform of t squared plus 4 times the Laplace transform of t plus 4 times the Laplace transform of 1. Gag. Right?
Those aren't bad stuff.
And then cubing is going to happen. So over here in the margin,
Is that the Pascal's?
this is Pascal's triangle, which I would definitely advise if you have anything bigger than cubing. I would really actually advise it for cubing too. So when I'm using this to cubing, I do 1t cubed plus 3t squared times 4
Plus 16 times 3.
plus 3, and I'm going to do it as t times 4 squared, just in case somebody's not sure what I'm doing.
Plus 4 cubed.
And then plus 1 times 4 cubed. Good with this? So all told here I got t cubed plus 12t squared plus 3 times 16 is 48 t, and then 4 times 4 times 4 is 64. Okay? So you need to bring that over. Oh.
We should probably do that. Combine like terms.
Yeah, okay. So let's combine like terms. So I got a t squared, that goes under the t squareds, a 16t, and a plus, wait, 16t. Okay, battery died. T squared plus 8t, 8. Spite you lot. Plus 16, and then I need a,
Oh, that's negative.
yeah, all that needs to be subtracted, right? So I'm just going to slap minus signs on everything.
Minus 1.
And then there's a minus 1 at the end. Let's see, so 64 minus 16 is 48, probably.
7.
So 47 and 40 t's and 11 t squared and a t cubed.
Don't need 43 T's? Oh, never mind.
Minus 8.
No.
I was going to talk
And then I got a plus e, so back to my Laplace transforming, right? I got an e to the minus 4s, and then I have the Laplace transform of all of that junk with linearity applied. So I got the Laplace transform of t cubed plus 11, oops, big parentheses, plus 11 times the Laplace transform of t squared plus 40 times the Laplace transform of t plus 47, and shit, that one's 1 over s. Done right, big L's. Cool?
Cool. We turned one Laplace into
Yeah, we turned the Laplace transform of one really nasty thing.
8 Laplaces.
Yeah, but they're all easy, right? So you just do it. So you got your 1 over s plus e to the minus 2s, and then in here you've got, okay, so the Laplace transform of t squared is 2 over s cubed, and then I've got 4 over s squared and 4 over s. And then in my last thing, I've got a plus e to the minus 4s, and then that's going to be times a, ooh, cool, that one's fun.
6 over
6 over s to the 4th plus 11 times 2, right? So 22 over s cubed plus 40 over s squared plus 47 over s. And there you are, check done. You could multiply that out and try to combine like terms, but they're
Not worth
No.
it.
no, they're not worth it. Not right now.
not ever.
You guys cool with this?
Yeah.
Yeah, so these are kind of a mess, right? But if you absolutely had to solve one problem like this, you definitely could. right? And the beauty of this thing is that you can start with discontinuous forcing functions and actually get an explicit answer, right? Which is pretty cool. There's not another good technique to do that. Laplace transform is the like go-to for discontinuous things. The other techniques I'm going to show you don't deal with it at all. They don't do a good job. They're just not going to happen. But this thing does discontinuous forcing functions, which is why it's still kicking around after all these years. Cool.